Out in the cold darkness, far beyond the edge of everything we have ever known, a tiny, battered machine is slowly reaching the end of its journey. Its nuclear heart is fading. Its instruments are shutting down, one by one. It carries no crew. It has no way to return home. And one day, Voyager will fall silent. Forever. At this very second, a faint whisper of electromagnetic energy is traveling across the cosmos toward Earth. Its power is astonishingly weak, less than a fraction of a billionth of a watt. A signal 20 billion times fainter than the battery powering a standard wristwatch. Yet, massive 70-meter radio dishes across our planet are turned toward the stars, straining to catch its voice amidst the cosmic noise. Today, Voyager 1 is more than 25 billion kilometers away from Earth. So vast is this distance that a radio command traveling at the speed of light takes over 22 hours just to reach it, and another 22 hours for its reply to return home. Nearly 2 full days for a single sentence in a conversation across the dark. In recent years, that conversation has drifted dangerously close to breaking forever. In late 2023, the spacecraft stopped sending back readable scientific data. Instead, it transmitted a repeating, incomprehensible stream of zeros and ones. A ghost code. A cry from a 50-year-old memory chip freezing in deep space. For months, engineers on Earth worked tirelessly, fearing the end had finally arrived. And while they achieved a remarkable miracle fix, the reality remains unyielding. Voyager is living on borrowed time. Its power is nearly depleted. Its instruments are freezing. So how did a simple machine, built in the mid-1970s, wander so remarkably far into the dark? To understand, we must travel back to a time before the internet, before smartphones, before humanity had ever seen the outer solar system up close. We must go back to a rare moment of cosmic geometry and a gamble that redefined our place in the universe. In the mid-1960s, a doctoral student at Caltech named Gary Flandreau discovered something incredible in his calculations. Once every 176 years, the 4 outer giant planets, Jupiter, Saturn, Uranus, and Neptune, align in a sweeping, perfect curve. A geometric alignment so rare that the last time it occurred, Thomas Jefferson was President of the United States. Flandreau realized that if a spacecraft were launched at the right moment in the late 1970s, it could use the gravity of each giant planet to sling itself toward the next. A trip that would normally require 30 years of heavy propellant could be completed in just 12. NASA named it the Grand Tour. It was a monumental, once-in-a-lifetime opportunity, yet it almost never left the drawing board. In the early 1970s, as the Apollo program drew to a close, NASA faced severe budget cuts. Congress canceled the multi-billion-dollar Grand Tour project. But engineers at the Jet Propulsion Laboratory refused to let the dream die. Quietly, they re-engineered the mission, proposing a modest trip to visit only Jupiter and Saturn. Behind the scenes, however, they built those spacecraft with extra durability, surplus fuel, and hidden capabilities, knowing that if everything went right, they could keep going. In late summer of 1977, Voyager 2 and Voyager 1 roared into the sky above Florida. They were not designed to conquer. They were built to observe. Two fragile seeds thrown into the cosmic ocean on a voyage with no return. To truly appreciate what Voyager is accomplishing today, we have to look inside the mind of the machine. Voyager was designed and built in an era before microprocessors as we know them existed. The computer on board Voyager 1 possesses a total memory capacity of just 68 kilobytes. To put that into perspective, a single digital photo taken on a modern smartphone contains thousands of times more data than the entire system that navigated Voyager across billions of miles. Its scientific data is stored not on modern flash memory, but on a custom digital tape recorder, a mechanical device with physical moving parts that has survived 50 years in the cold vacuum of space. Because intense cosmic radiation destroys delicate microchips, engineers chose simplicity and rugged reliability over processing speed. There are no touchscreens, no automatic software updates. Every command beamed to Voyager today is typed out by engineers on Earth, translated into binary code, and transmitted across the solar system. When those commands arrive nearly a day later, Voyager executes them using code written during the era of typewriter paper and analog tape. It is a masterwork of human engineering, an antique explorer performing a journey no modern spacecraft has ever replicated. In March 1979, Voyager 1 plunged into the gravitational domain of Jupiter. What it revealed fundamentally transformed planetary science overnight. Instead of quiet static gas spheres, Voyager unveiled a world of violent atmosphere and dynamic beauty. It captured Jupiter's Great Red Spot, a storm larger than Earth itself, churning with immense force. It discovered faint, hidden rings around the giant planet. And then came the moons. Engineers expected frozen, inactive rocks. Instead, on Io, Voyager discovered active volcanoes blasting plumes of sulfur 90 kilometers into space. The first active volcanism ever observed beyond Earth. On Europa, it captured images of a fractured icy shell, hinting at a deep ocean of liquid water beneath. Accelerated by Jupiter's massive gravity like a slingshot, Voyager surged toward Saturn at over 60,000 kilometers per hour. In November 1980, it arrived at the ringed planet, revealing that Saturn's rings were composed of thousands of delicate icy wave structures guided by tiny shepherd moons. Then, Voyager turned toward Titan, Saturn's largest moon, shrouded in a dense orange atmosphere. Scientists faced a major choice: send Voyager 1 close to Titan to analyze its complex atmosphere, or preserve a trajectory toward Pluto. They chose Titan. Voyager swept past the moon, confirming an atmosphere rich in organic molecules and methane clouds. That trajectory angled Voyager 1 upward, out of the ecliptic plane, directing it toward the northern crest of our galaxy. Its planetary flybys were complete. Behind it lay the gas giants and the inner worlds. Ahead of it lay only the vast, uncharted dark. While Voyager 1 climbed out of the planetary plane, Voyager 2 carried on the grand tour alone, discovering the icy blue worlds of Uranus and Neptune in late 1980s. With Neptune behind them, both spacecraft entered uncharted territory. For billions of miles, the Sun's radiation creates a protective bubble known as the heliosphere, shielding our planetary system from interstellar cosmic rays. No human instrument had ever reached its boundary. Then, in August 2012, more than 35 years after leaving Earth, Voyager 1's sensors detected a profound transition. Solar particles vanished. Galactic cosmic rays spiked sharply. Voyager 1 had crossed the Heliopause. It had passed beyond the Sun's protective sphere and stepped directly into interstellar space. For the first time in human history, an object built by our hands had left the home solar system behind. What does it truly mean to exist in interstellar space? It means our Sun is no longer a warm, golden sphere in the sky, but a brilliant point of light among billions. There are no planets nearby, no warmth, no atmosphere. The background temperature hovers just 3 degrees above absolute zero. Here, in the interstellar medium, Voyager glides through an ocean of dilute plasma and galactic magnetic fields. Though moving at 38,000 miles per hour, space is so vast that the probe appears completely motionless. It will travel for 40,000 years before coming anywhere near another star system. Yet even here in the deep silence, this remarkable machine continues to measure the cosmic wind and talk to us across the light hours. It remains our eye, our ear, and our singular voice in the deep galaxy. In recent years, keeping Voyager operational has become a quiet, determined battle against time and physics. At this distance, solar panels are useless. Voyager relies entirely on radioisotope thermoelectric generators, powered by decaying plutonium-238. As the plutonium decays, Voyager loses roughly 4 watts of electrical power every year. To preserve its life, engineers on Earth have made tough decisions, shutting down heaters, deactivating non-essential systems, and powering off science instruments one by one. When computer memory failed in late 2023, JPL engineers meticulously rerouted code across different sections of Voyager's 50-year-old memory bank. On April 20th, 2024, after nearly 2 days of waiting, the clean signal returned. Voyager was restored once again. These engineers, many born long after the probe launched, continue to preserve this unique bridge to interstellar space. Yet the laws of physics are absolute. By the late 2020s or early 2030s, electrical power will drop below the threshold required to operate even a single instrument. The final transmitter will click off, and its voice will gently fade into the background noise of the galaxy. When Voyager eventually goes quiet, its voyage will not be over. In many ways, its longest chapter will have just begun. Mounted firmly to its chassis is a 12-inch gold-plated copper phonograph disc, the Golden Record. Curated by Carl Sagan and his colleagues, it carries spoken greetings in 55 human languages, natural sounds of ocean waves, thunder, and animal calls. It contains musical masterpieces from Bach and Beethoven to Chuck Berry, along with encoded images of our civilization and scientific knowledge. In 1990, as Voyager 1 approached the outer edge of our planetary neighborhood, Carl Sagan requested one final image. From 6 billion kilometers away, Voyager looked back and captured Earth, a tiny, fragile point of light suspended in a ray of solar glare. The pale blue dot. Every story, every life, and every chapter of human history took place on that single pixel. Long after our cities have changed, long after our planet's distant future unfolds, this golden capsule will drift peacefully through the stellar sea, a silent monument to a curious species that looked up at the night sky and reached out into the universe. Long after humanity is gone, long after Earth has changed beyond recognition, Voyager will still be traveling, silent, alone, carrying a small golden record, waiting for someone, somewhere, to discover that once, in a quiet corner of the Milky Way, a curious civilization looked up at the stars and decided to say hello.